All on the same page. So who knows what that is? One what? One term is, yeah, I don't know what meal is either. So one term is what we say, right? So one term. And why is it one? How'd you guys get one? Mono, okay. Okay, so then what would be the next one up?
Poly.
Well, that's, no, well, we'll get to that in a second. Bi would be the next one. Okay, so then what's that? Two terms, okay. What's the next one? Trinomial. All right, yeah, there could be quadnomial, whatever, but then what do you call them though? Yeah, so then it's poly. But what does poly mean? Yeah, or many, however you want to say it. So the real question is a monomial a polynomial? Why not? No, that's a good argument. But I would argue that it is because many concludes everything. So, yeah, so any amount of terms. Like the example I gave before was, a triangle is still a polygon, even though, it's only three. You would call it a triangle. So, all right, so this is all great, but we do need to make sure we know what a term is, which is surprisingly difficult to define. So we better do that. So what's a term? Okay, so that's pretty close to the whole thing. So any number or variable. Oh boy. Got it, Trent. Or what else? That's almost the whole thing. We can do this by examples also. So give me an example so far of what we have. 2x. No, actually, that's not what we have yet. But we need that part in there too. So 2 and x.
Oh, so it's a mix of the two.
Or a combination of the two, yeah. Okay. So 2x works. Can you give me a more elaborate one?
Just one term?
So yeah, right, yeah, just like a single term, like something really sexy, like right. You see that in the, you see that at the dance. You're like, I need to know about what's going on over there.
25W.
Yeah, I mean that's barely, just because you're using W doesn't. That's it's the same. It's just like, oh look, they got blue socks on today. So, like I'm talking about where it's like you're in the middle of talking to your best friend. You're like, what, who, huh? What? I mean, give me something like this is like your deepest term fantasy here. Like, when you guys are trying to fall asleep at night, you think about this term. You're like, the way your exponents, they're just, it's all in there together. Yeah.
26xy to the third power.
That's what I'm talking about there. Look at that. Dylan, we know about Dylan now. Freak, you little freak. Come on, man.
Oh my God.
Yeah, good, right? All right, so it could be anything, really. How are they separated though? How do you? Because we just talked about binomials and trinomials. How do you know how to get more than one term? Adding and subtracting. Yeah, so these are separated by adding and subtracting signs. Okay. So now we're going to go back after, I'll give you a second, and we're going to go back and we're going to give some examples of, well, these are all monomials, so then we'll just do binomials and trinomials. So, give me an example here.
6x plus 25x squared.
Yeah, that'd be a good one. Right, what about a trinomial? How about a trinomial?
Trinomial?
Yeah, give me one.
6x plus 5x.
Well, that's kind of not, because you combine those terms, right?
6x squared.
So 6x squared plus 5x cubed. That's it. Minus 2, sweet.
Yeah, that's good.
All right?
I was going to find the exponents after I was done listing out the numbers.
All right, terms down. What about like terms? All right, so he gave the example of 5x and 7x. So, no, that's not an x. 5x and 7x. So why are those like?
Terms with the same variable.
And a little bit more of that. Terms with the same variable and exponent. Okay? So these must be like terms, right?
Yeah.
But you said same variables and exponent. They both got 2.
The exponent has to be in the same place, though.
All right, yeah, it has to be in the same place. Okay, thank you. Not like terms.
Yeah.
All right, what about this one then? This is my favorite question. Well, that's not even true. It's kind of like we live in the greatest time ever. It's like, well, really? Are you just saying random things that come to your mind?
Yes.
Wait. I have to pause for this. All right, so are those like terms?
Yes.
Okay. They're not in the same place, so why are those like terms? You can multiply in any order you want, right? All right, very good. All right. One more example problems, and then I'm done. Combining.
Like term.
You got it. So how do you combine like terms?
You combine them, put them together.
Add and subtract them. So what is the only thing, and this thing is what you call part of a term, what is the only part of a term that should be changing when you're adding and subtracting them? The sign might change, but that's like, the coefficient is the only thing that should change. What should not change? And the exponent is more worrisome to me, okay? So make sure you understand that. But of course you have to know what a coefficient is. What is a coefficient? Well, it is a base, but the number out front, right? Not the exponent, okay. Okay, so that's a lot of things, because I say a lot of things, and you got to know what I'm saying. So, any questions so far? So, first question, how do you know we're subtracting here? The big subtraction sign where? There's a bunch of them. Okay, so then this is not a FOIL problem, so stop making this into a FOIL problem. Those of you that keep doing that. This is a big subtraction problem. What is the significance of the parentheses if the directions are subtract polynomials? So we have 2 polynomials up there, and that's why they have parentheses, because this is one of the polynomials and that's the other polynomial. Right? Is that okay? Nope, 2. 2, 2, 2. All right, so why am I picking a subtraction problem instead of an addition problem?
Because you have to distribute the subtraction to the right.
Yeah, so the whole point is that you're subtracting, and what you don't want to do is make problems harder for yourself by having to say minus negatives and things like that. So the easiest thing to do is just distribute a -1 to everything in the second parenthesis. What about the first set of parentheses? Leave it alone. Okay, so I'm just going to rewrite it then. And so then distributing a -1 just means all the signs change. And now you don't have to worry about anything. You're just going to, you're just going to combine like terms. So Trent, is there any like terms out there?
Oh, yeah, there's a bunch.
Well, let's do it, man. Like, pick one. Pick a set.
4x squared, y squared would go with 9x
Okay, I don't see a 4x squared y squared.
negative.
-4x squared y squared. You should say what you mean. So you combine those, and what do you get? Lesson.
Thanks.
5x squared y squared.
5x squared y squared. People can't stand to watch you fumble around. All right, Trent, give me another set of like terms.
10xy and 7xy,
What do those give you?
17xy.
So plus 17xy. Get Trent, finish it off.
You want me to?
I would love for you to participate, yes.
Alright, -3y cubed with -4y cubed.
All right, what do you get?
7.
What did you get?
7y cubed.
-7y cubed. Can you go any further? Why not?
Not like terms.
Not like terms. Is that in order?
No.
Actually, it is in order. But I'm not concerned about the order as long as your signs are right. That is actually in order. It goes alphabetically and by the biggest exponent. So it is actually in order. Alphabetically first. So is that okay?